Now I'm just going to run through the program, the built-in program for the 3x3 matrix operations. So to load that program, we are going to go to the program space, load, and then D. So that said 3x3. We have that program loaded, so let's exit this. So we're going to enter in our matrix here, our system of equations. So that's going to be our 1, 1, it's going to be our 2, 1, or 1, 2, and then 1, 3, and etc. So I use the keyboard here. So this is going to be this, I'm going to store in register 7, my first coefficient, register 8, my second coefficient. So I'm going to follow this pattern here. So 19, I'm going to store that in 7. Negative 4, I'm going to store that in 8. And 4, I'm going to store in 9. 5, I'm going to store that in 4. Negative 12, store that in 5. And negative 10, store that in 6. And negative 15, store in 1. 8, store in 2, and 3, store in 3. So I have this matrix entered right now, and I can go ahead and find the determinant if I want. I just execute and then label D, and that gives me the determinant of negative 264, which is correct. But I want to enter in my numbers here, so that's going to be my B matrix, and to enter that, I'm going to first enter the first number, so 5, and store that in register 0. And then the other two numbers I'm going to separate with the input. So negative 3 and input 4. So I've got all three of those coefficients stored in there. Yes, it does seem strange to me to store it in 0 and then have the other two in the separated by the input, but that's the way it's designed. So execute A. And that gives me negative 1.67 as my x1 value. Hit run stop. That gives me negative 4.41 as my x2 value. Run stop, and 4.76 is my x3 value. So we just solved for x1, x2, and x3, or x, y, and z in your system of equations. The other thing we can do here is take the inverse of this equation, of this matrix. So we're not caring about the coefficients, the answers. We just have a matrix at this point. I'm just saving steps by having it in. So we're going to do our identity matrix here of 1, store that in 0, and then have 0, separate 0, and then execute A. So this gives us the first column. So negative 0.17, run stop, negative 0.51, run stop, and 0.53. To get the second column, I'm going to store 0 and register 0, and then I'm going to have 1 separated by 0. Does that make sense what I'm doing? So I multiplied it by that first, and now I'm doing this, and then of course lastly we'll do that. So same thing, execute A, we get negative 0.17, run stop, negative 0.44, run stop, 0.35. So let's do that last one. 0, store in the 0 register, 0 separated by 1, and execute A. We get negative 0.33, negative 0.80, and 0.79. So it takes a little getting used to. I think remembering these for your matrix that you're entering, this sort of visual pattern is helpful. And remember the first number of your secondary, your 1x3 matrix, is going to be stored in 0, and then separate the next two by the input button.